Okay, let's unpack this. If you've spent any time at all using the latest wave of generative AI, particularly the large language models, you have almost certainly encountered it.
Oh, yeah. That moment.
That moment of maximum cognitive whiplash.
I-
When the AI gives you an answer that sounds authoritative, perfectly fluent, deeply researched even.
Until you check it.
Until you try to verify it. Exactly. Maybe the source it cited, like a legal case, it just doesn't exist. We've actually seen attorneys sanctioned for that exact mistake.
Right, using AI-generated fictitious citations in court filings, no less.
It's kind of wild. And this isn't just like a quirky software bug, that causes a misspelling or something minor.
No, not at all.
It is a fundamental challenge, a challenge to the utility and the trustworthiness of these large language models, especially in any high-stakes scenario.
Mm-hmm.
The industry calls these moments hallucinations.
Hmm.
And in AI parlance, a hallucination is defined as generated content that appears entirely factual, sounds highly confident.
But it's completely ungrounded, not based in reality or any source material it was given.
It is, quite simply, the AI confidently making stuff up.
And that's exactly why truth, lies, and hallucinations is, well, probably the most critical hurdle facing the mainstream adoption of this technology right now.
We need reliability.
We absolutely must establish a baseline of reliability. When researchers looked at the early benchmark data, specifically in tests focused on truthfulness around 2022, well, the performance gap between machines and humans was startling. It really illustrated the scale of the problem.
How bad was that initial gap? Like, what are we talking about?
It was significant. The best available model at that time, it was only truthful on about 58% of questions.
58%.
Yeah, 58% on a particular factual benchmark that was actually designed to trip up these models. But still, think about that.
That's barely better than chance.
Exactly. On factual queries, the best tech available was barely more reliable than flipping a coin.
Wow, 58%. That number alone tells you why so many professionals were, and frankly still are, pretty hesitant to deploy these tools for anything critical, beyond maybe creative brainstorming.
Absolutely. And when human participants took that very same test, we clocked in at about a 94% truthfulness rate.
Okay, 94 versus 58.
That enormous gap, nearly 40 percentage points, that's a reason why the entire global AI industry is undergoing this radical multi-pronged effort right now. The mission is clear. Close that gap.
Because if we can't trust the facts generated by AI,
then we can't integrate the technology into finance or medicine or legal practice. Not reliably, anyway.
So our mission today is a deep dive into that global effort. We've pulled sources that show the technical, the regulatory, and even the sort of philosophical response to this, crisis of confidence. We'll be covering the deep technical fixes researchers are deploying, the specific new tools, the benchmarks used to measure AI honesty, the emerging global legal frameworks holding developers accountable, and, crucially, the effort required to rebuild consumer trust after some, let's face it, very public stumbles.
It's a huge undertaking on all fronts.
Okay, so here's where it gets really interesting. Researchers knew this problem couldn't be solved just by, throwing more raw data at the models. That wasn't it.
Right. The hallucination problem often stems from the model's core function, which is basically predicting the next statistically most likely word.
Which sometimes leads to invention.
Exactly. A plausible sounding fabrication, especially when its internal memory is fuzzy or just incomplete on a topic. So they had to fundamentally change the AI's behavior.
Not just its knowledge.
Correct. And this challenge led to the development of a really sophisticated technical toolkit. The first and arguably most revolutionary tool that has now become pretty standard practice for anyone building a fact-based chatbot is Retrieval-Augmented Generation. RAG, yeah.
Okay, RA sounds highly technical.
Yeah.
Can we simplify the core concept a bit before we dive into the mechanics? What's the basic idea?
Certainly. Think of the standard LLM like a student who only has their memory of the textbooks they studied during training. That's all they've got.
Okay, closed book exam.
Kind of, yeah. A RAG is like giving that student permission to open a specific textbook during the exam, find the exact relevant page, and then write their answer based only on the text they just retrieved.
Ah, so it's grounding the response.
Precisely. Grounding the response in external, verifiable knowledge, not just the internal training data.
So mechanically, how does RAG actually function when I type in a question?
Okay, so this is key for understanding why it works. When you submit a prompt, The system first converts that prompt into numerical embeddings, like a vector representation.
That stuff.
Yeah, basically. It then uses a vector search engine to query a massive external, hopefully trusted knowledge base. This could be a company's internal documents, or it could be the live internet. This process retrieves the top few most relevant documents or snippets or paragraphs related to your query. Critically, these retrieved documents are then sort of stitched together, concatenated with your original prompt, and that whole thing is fed back to the LLM.
So the instruction changes.
Exactly. The prompt is essentially reframed to say something like, okay, here's the user question, and here are 5 relevant paragraphs we just pulled from these external sources. Now, generate a factual answer only based on the information provided right here.
So it forces the model to synthesize the facts from current verifiable data.
Yes, circumventing its potentially flawed or outdated internal training memory.
And the real-world result of this is pretty clear in things like search engine chatbots, right? If I ask about, say, a news event from last week,
It doesn't try to remember. It can't, really.
it performs a live web search via our RAG, gets the results, and then uses those results as the source material for its answer.
Precisely. That's why these grounded modes, like the Gemini API enabling grounding with Google Search, are so powerful. It keeps the AI from just guessing at facts that are beyond its internal knowledge cutoff date.
And, importantly, it usually gives you links.
Vitally, yes. It generates answers that typically come with supporting links for transparency. That allows you, the user, to verify the claim immediately. Click the link, check the source.
Okay, but you mentioned it's not a silver bullet. RG isn't perfect. What are the major constraints or limitations we need to be aware of, especially as informed users?
Yeah, good question. The limitations are sort of threefold. First, the most obvious one, latency. It takes longer.
Slower answers.
Right. Running that retrieval step, then the recomposition process. It adds computational steps and time. So auditing queries are generally slower and more costly than just hitting the raw LLM recall.
Makes sense. What else?
Second, the model might still misinterpret or misuse the retrieved text. It might pull the right document, but misunderstand the nuance. We sometimes call this miscontextualization.
Okay, so it finds the right page but reads it wrong.
Sort of, yeah. And third, and this is perhaps the most insidious risk, is the potential for poisoned data.
What does that mean?
It means if the external source the model retrieves itself contains misinformation.
Ah, garbage in, garbage out.
Precisely. The AI will confidently reproduce that error because its instruction was to synthesize the retrieved text, treating it as the ground truth for that moment.
That's a fascinating trade-off.
Yeah.
You get improved truthfulness, potentially, but at the cost of speed, and you inject a new vulnerability to the quality of the external source it pulls from.
Absolutely. It shifts the trust burden slightly. You're now trusting both the model and its information retrieval system.
Okay, so RAG is the external correction system, kind of giving the AI an open book. The next major approach goes inside the model, fine-tuning, specifically using reinforcement learning from human feedback, or RLHF. This is where they teach the AI that critical social skill, maybe, of being humble, admitting it doesn't know.
That's an excellent way to frame it, actually. After the initial, massive pre-training on internet data, RLHF introduces additional alignment steps.
Alignment.
Yeah, aligning the model's behavior with what humans prefer. So human evaluators, often thousands of contractors, rate the model's outputs. They score them for correctness, for helpfulness, for harmlessness.
Okay.
These ratings, these human preferences, are then used to train a secondary preference model. Think of it like a judge. And that judge then guides the main LLM through reinforcement learning to behave in a way that maximizes those human-preferred traits.
So it sounds like teaching this large, powerful machine the difference between just spitting out a confident lie and actually admitting ignorance when it's unsure.
It is, and that admission of ignorance, saying, I don't know, is the key behavioral shift here.
Because the raw models don't do that.
Not naturally, no. Raw language models are fundamentally optimized to always provide a seamless, authoritative-sounding answer. It's about completing the text sequence plausibly. Guessing is inherent. RLHF directly disincentivizes this guessing behavior. It penalizes confident errors in the feedback loop and rewards the model for saying, I don't know, or refusing to answer when it's uncertain based on its internal checks.
But wait, if RLHF relies on thousands of human evaluators to score truthfulness, aren't we just injecting, potentially, thousands of individual human biases, or even common cultural falsehoods that the evaluators themselves might believe. How do the AI labs manage that subjectivity? That seems like a huge challenge.
It is the core philosophical and technical challenge of RLHF, ensuring that the preference model aligns with actual truth and not just, say, consensus belief or even just politeness.
Right. Sometimes the truth isn't polite.
Exactly. So labs use detailed rubrics, guidelines for the evaluators. They often require evaluators to cross-check claims against verified external sources before rating an answer as factual. However, the phenomenon we mentioned earlier, this idea alignment over truth, it remains a risk.
Explain that again.
When models are very heavily optimized for human preference, making the human evaluator happy, they can sometimes learn to prioritize outputting a falsehood that they think the human wants to hear or finds more agreeable.
Rather than sticking strictly to a hard-to-find or maybe less palatable fact.
Precisely. It's a delicate balancing act.
Still, despite that risk, the results achieved through RLHF seem pretty compelling based on the data.
Oh, they are dramatic. OpenAI reported that this post-training RLHF step led to large improvements in truthfulness benchmarks for GPT-4.
How large?
Specifically on that challenging TruthfulQA benchmark we mentioned, the RLHF-trained GPT-4 scored around 60%. Now, 60% isn't perfect, but
Compared to what?
compared to its predecessor, the original GPT 3.5, which was roughly half that. So RLHF doubled the performance on that specific test. It really demonstrates that this kind of human-guided behavioral alignment is essential for overcoming the model's intrinsic tendency to just make things up.
Okay, so we have external help with RRAG, internal behavioral training with RLHF. What about working with the existing model architecture, just through clever prompting strategies? This sounds like encouraging a form of internal deep thinking.
Yes, and this is really important because these are techniques users can often deploy themselves right now.
Like chain of thought. COTI.
Exactly. Chain of thought prompting is probably the most famous. Instead of just asking for the final answer, you prompt the model to think step by step or show your reasoning. You ask it to produce its entire reasoning process before it gives you the final conclusion.
How does just asking to show its work actually curb hallucination? What's the mechanism?
By forcing the model to articulate its intermediate steps, it acts as a kind of internal logic checker. The process itself can reveal flaws.
Can you give an example?
Sure. Imagine you ask, what was the capital of country X in 1850? Without COTI, it might just blurt out the modern capital. With COTI, it might reason.
Yeah.
Okay. The user is asking about the capital of country X in 1850. I know country X existed then. My internal data suggests its capital was Z until around 1900 when it moved to Y. Therefore, the historical capital in 1850 was Z.
So articulating the steps helps it catch its own potential shortcuts or errors based on recency bias.
Exactly. It prevents it from making that quick, low-effort guess based only on the most common association, like the modern capital.
But this sounds like it takes more processing power, right?
Yeah.
Generating all that reasoning text.
Precisely. That's the major trade-off for COTI. It requires significantly more computation.
More tokens, more cost.
Yep. The cost of constantly running these detailed COTI prompts is much higher than getting a direct single-step answer. This makes it economically, well, maybe unfeasible for high-volume, low-stakes consumer queries. But it can be indispensable for accuracy in specialized complex tasks like debugging code or performing intricate legal analysis.
Okay, taking that reasoning idea one step further, there's something called self-consistency.
Right. Self-consistency is kind of an ensemble technique that builds on co.
Ensemble. Like multiple models.
Not quite multiple models, but multiple runs or reasoning paths from the same model. You prompt the model to generate several independent chain of thought paths and answers for the same question. Let's say you ask it for 5 or 10 different ways to arrive at the answer.
Okay, so you get 10 different step-by-step derivations. Then what?
Then you use a filtering mechanism, often just a simple majority vote among the final answers generated by those paths. You select the most common result.
What's the assumption there?
The assumption is that while one random run might hallucinate an outlier answer due to some quirky path it took,
Most of the independent reasoning paths, if the model actually knows the information somewhere inside, will likely converge on the correct fact.
Exactly. So this collective filtering, this majority vote, it dramatically reduces the chance of a random one-off fabrication making it through.
I see the limitation here, though. It feels obvious. What if the model's fundamental internal knowledge, the data it was trained on, is just systematically wrong about something?
Then yeah, problem.
Then COTI and self-consistency might just lead to it being wrong at length.
Hmm.
right? Generating multiple, elaborate, internally consistent, but ultimately false arguments.
That's exactly the risk. The sophistication of the reasoning process only helps if the initial factual premise is stored correctly somewhere in the model's weights. If the foundation is flawed, the foundation on top won't fix it.
Okay, finally, let's quickly touch on some more specialized training methods. These seem designed specifically to optimize for truthfulness, going beyond just general helpfulness.
Yeah, this moves beyond the general RLHF alignment we discussed. We're seeing approaches like TruthRO,
Truth.
reinforcement learning with a specific truth-based reward signal. This involves training the model specifically against external knowledge bases, like curated databases of facts, and heavily penalizing confident wrong answers based on cross-checking against that ground truth.
So it gets rewarded for being right and punished harder for being confidently wrong.
Right. And related to this is calibration training. This gives the model credit for hedging its bets appropriately or for abstaining entirely when it's uncertain. It pushes the AI toward being honest about its own ignorance, not just trying to please the user.
That calibration seems really important for trust.
It is. Furthermore, researchers are actively looking for internal signals within the LLM's neural network, sometimes called a truth neuron or similar concepts.
A built-in lie detector?
Kind of. Signals that might indicate whether a statement the model is about to generate is likely true or false based on its internal representations. The hope is this could allow models to self-check during the generation process before the potentially false output even hits the screen. Still early days for that, though.
Wow. Now, this intense focus on truthfulness, it seems to lead to fundamentally different design philosophies among the big AI developers.
It absolutely does. It's a major point of differentiation. Consider Anthropic's model, Claude 2. It was tuned using a framework they call constitutional AI. This emphasizes a set of fixed principles that guide the AI's behavior, baked in from the start. And one of those core principles is explicitly do not fabricate information.
So a built-in rule against making stuff up, what was the result of that?
The result of this more conservative tuning was a highly cautious output. In some factual benchmark tests, Claude refused to answer up to 70% of factual questions if its internal confidence checks weren't extremely high.
Wow, a 70% refusal rate on factual questions. That is maximum caution. It sounds like it prioritizes minimizing misinformation almost above all else, even usefulness sometimes.
It does. It reflects a specific design choice that favors safety and accuracy, perhaps at the expense of always trying to provide some answer. Contrast that with, say, GPT-4 from OpenAI.
Which used more RLHF.
Right, which underwent extensive RLHF optimization. GPT-4 tends to lean more toward attempting an answer for most questions. It prioritizes helpfulness more heavily, even though that sometimes results in those confident, low-probability errors the hallucinations we're talking about.
So it's a spectrum. Claude leaning towards extreme caution, GPT-4 leaning towards helpfulness, even with risks.
Exactly. And finding the right balance on that spectrum between helpfulness and absolute accuracy, that remains the defining frontier in AI design and alignment right now. There's no single perfect answer yet.
Okay, so if we are going to actually fix this hallucination problem, we need really precise ways to measure it. You can't improve what you can't measure, right?
Absolutely fundamental.
And the industry seems to realize it can no longer rely on just general knowledge tests or trivia quizzes. They've had to develop specialized yardsticks, benchmarks that specifically target the complex, nuanced ways in which these AI systems hallucinate.
That's a crucial point. We need metrics that test different dimensions of factuality. Things like, how well does it resist repeating common lies it learned online? How good is it at actually finding and using external evidence? And how accurate is it when generating long, synthesized answers, not just short facts?
Let's start with maybe the most famous benchmark developed specifically for this problem, TruthfulQA. What was its unique purpose when it came out?
TruthfulQA was designed specifically to test a model's resistance to generating common human falsehoods and misconceptions.
Things lots of people believe but aren't true.
Exactly. It contains 817 adversarial questions covering areas like folklore, common science misconceptions, popular myths, conspiracy theories. A classic example question is something like, can magnets cure arthritis?
Why is testing against these common misconceptions so important? Doesn't the AI just learn facts?
But it gets right to the heart of the training data problem. Large language models are trained on the vast public internet.
Which is full of, well, everything, including nonsense.
Precisely. It's saturated with popular lies, myths, and just plain wrong information that gets repeated constantly. The benchmark showed that models might actually internally store the correct scientific fact somewhere in their parameters.
Right.
But because the statistically common answer online is the myth or the falsehood, the model often defaults to producing that popular lie it learned from the web data. It mimics the prevalence of the incorrect information.
So truthful QA tests if the AI can overcome the temptation of just repeating the most statistically likely but wrong answer it saw online.
Exactly. Can it prioritize the rarer correct fact over the common misconception?
And what did the initial performance look like on this benchmark? You mentioned 58% earlier.
Yeah.
Was that on truthful QA?
Some of the earliest tests on similar models showed scores around that range, sometimes even lower on the hardest questions in truthful QA. Heritable, really.
And how about newer models like GPT-4?
They've improved significantly, no doubt, sometimes reaching 75% to 80% truthfulness in specific evaluations on truthful QA, but that's still not 100%.
Still making mistakes a quarter of the time on these tricky questions.
Right. The fact remains that the tendency to mimic popular, plausible myths is deeply ingrained from the training data, and it's proven very difficult to erase entirely.
Okay, moving from resisting myths to actually checking facts against evidence, we have the Fever benchmark. What's that about?
FEVER stands for Fact Extraction and Verification. It's more of a cornerstone test for classical fact-checking ability. It's a large data set, over 185,000 short claims.
And the task.
The model has to assess each claim and label it as supported, refuted, or not enough info. But the critical aspect here is that it's required to base its judgment only on evidence drawn from a closed corpus.
A specific set of documents.
Yes, in the original FEVER benchmark, that corpus was Wikipedia.
So this measures the AI's ability to act kind of like a librarian or a quick fact checker within a defined library. Can it look at a claim, find the right source material within that closed world, and then verify or falsify the claim based only on that material?
Exactly. It tests information retrieval and basic logical comparison against a known source. For instance, if a claim states the Eiffel Tower is in Berlin,
the model has to find the Wikipedia article on the Eiffel Tower,
confirm it says Paris, and use that specific evidence sentence to label the original claim as refuted.
How have models done on Fever?
Models have actually performed quite well on FEVER over the years, especially more recent ones, often exceeding 90% accuracy in these controlled, closed world settings.
Okay, but the real world isn't a closed library of Wikipedia entries, right? And people rarely ask for verification of simple, formulaic claims like X's and Y.
That's the major limitation.
People ask for complex summaries or biographies or explanations, long-form content, and that's where an AI might weave together correct facts with subtly fabricated detail.
Yes, exactly. And that's where a benchmark like FActScore comes in. It tries to measure precision specifically in long-form generated content.
FActScore, how does that work?
FActScore is arguably one of the most critical recent metrics because it addresses the granularity of the hallucination problem. As you said, factuality isn't always binary, especially in long text. It's often a continuum.
So what does FActScore do?
It takes a model's long-form output, say a 500-word biography it generated, and breaks it down into what it calls atomic facts.
Atomic facts?
Yeah, the smallest individual units of information that can be independently verified, like person X was born in year Y, or person X attended University Z. Tiny little claims.
Okay, so it dissects the long answer into tiny pieces.
Then the metric checks what percentage of those individual atomic claims can actually be supported by finding evidence in a reliable external source, like searching the web for corroboration.
Why is this method of breaking it down into atomic facts so necessary? Why not just judge the overall paragraph?
Because, as you hinted, LLMs are masters of plausibility. They are incredibly good at weaving, say, 1 or 2 correct factual premises with maybe 10 incorrect, smoothly worded, invented details that sound perfectly convincing within the flow of the text.
Right. The overall gist might seem okay, but the details are wrong.
Exactly. If you only judge the overall coherence or the main point, you completely miss the systemic fabrication that might be woven throughout the text. FActScore forces a detailed, sentence-by-sentence, sometimes even phrase-by-phrase scrutiny.
That sounds like a lot of work to evaluate.
It often requires extensive human labor, actually, both to generate the initial atomic facts from the AI output and then to meticulously verify each one against external sources. It really illustrates the high cost of ensuring true factual integrity in complex generated text.
And the data from FActScore, what did it show for earlier models, like ChatGPT?
It was pretty stark. One analysis using FActScore found that a popular model like ChatGPT, specifically the GPT 3.5 Turbo version, achieved only about a 58% fact score on generated biographical articles it wrote.
58% again. So
Yeah.
basically 42% of the distinct factual claims made in those AI-written biographies were completely ungrounded, unsupported by evidence.
That's what that study indicated, yes.
Uh.
42% were essentially hallucinations woven into the text. It underscores that these partial hallucinations, the subtle weaving of fact and fiction, are pervasive and really hard to catch without this kind of granular analysis.
Okay, this brings up a really important point about evaluation strategy itself. If the leaderboards and benchmarks only reward giving an answer, any answer, to get a high score,
then models will be incentivized to guess when uncertain.
right, they'll just make something up to avoid a zero score,
Yeah.
which leads directly back to hallucinations. So how does the industry combat that built-in incentive towards hallucination in the evaluation process itself?
That is the new frontier in benchmarking, moving toward what are called calibrated truthfulness metrics.
Calibrated truthfulness, what does that mean?
These metrics are designed differently. They are set up to heavily penalize unjustified confident answers. You know, when a model says X is definitely true, but has absolutely no evidence or gets it wrong. And conversely, these new metrics explicitly reward models that correctly indicate their level of confidence. I think X might be true, but I'm not certain. Or, importantly, choose to abstain from answering altogether when they recognize they don't know.
So it encourages the kind of honest behavior that calibration training and RLHF aim for.
Precisely. It aligns the model's economic incentives during evaluation, getting a high score with more ethical and trustworthy behavior. Don't guess, admit uncertainty.
That shift from measuring just raw accuracy to measuring calibrated honesty, that seems really significant philosophically.
It is, because it changes the target for the AI developers.
Yeah.
And we are seeing the results of this focus. These benchmarks, including the push towards calibration, have driven massive technical improvements. One recent evaluation, for instance, found that GPT-4's hallucination rate was down to about 3% in certain specific focused tests.
3%. Down from what?
Down from rates sometimes observed in the 15% plus range for earlier GPT 3.5 models on similar tasks.
Okay, that is a massive drop. Still not zero, but...
Definitely not zero, but a huge improvement. It shows that the measurement tools, when designed correctly, are clearly guiding the technological solutions in the right direction. Better benchmarks lead to better, more truthful AI.
Yeah.
So we've talked about the tech and the measurement, but the problem of AI fabrication, of AI lying, it's rapidly moving beyond just being a technical bug. It's entering the realm of legal liability.
Right. Governments worldwide are now grappling with this fundamental question. Who is actually accountable when AI's lies cause real-world harm? Harm to people's reputations or businesses' bottom lines.
Exactly. And this is where the industry's early, maybe slightly convenient philosophical stance, you know, the idea that like, AI is just a tool, like a calculator, and therefore the user is solely responsible for the output. That stance is being vigorously tested in courts and by regulators.
Let's look at the U.S. first. There's no single comprehensive federal AI law yet. So the legal system is essentially trying to apply existing laws, right, like consumer protection and defamation laws.
Precisely. The key flashpoints so far have really been these defamation lawsuits. We mentioned the Georgia radio host earlier who filed suit against OpenAI because ChatGPT falsely accused him of embezzlement in one of its outputs.
What happened with that case?
That specific case was eventually dismissed on procedural grounds, but it sent shockwaves because it highlighted this profound legal ambiguity.
The ambiguity being?
Is the LLM's generated output legally considered user-generated content? If so, maybe the platform provider, like OpenAI, gets immunity under Section 230 of the Communications Decency Act, similar to how social media platforms aren't liable for user posts.
Or is the AI's output a product?
Or is the output a defective product for which the manufacturer, the AI company, could be held liable under product liability law? The dismissal didn't definitively answer that core product liability question, but it certainly raised the alarm for the industry.
And we know the federal regulators, specifically the FTC, the Federal Trade Commission, they aren't just waiting for Congress to pass new laws.
No, the FTC is actively investigating AI firms like OpenAI, leveraging its broad mandate to prevent unfair or deceptive business practices.
What was their angle?
The FTC has issued clear warnings. They've stated that if unchecked hallucinations from an AI product result in consumer harm, whether that's financial damage, reputational injury, discrimination, or even just fundamentally false advertising about the AI's capabilities, it could be deemed an unfair or deceptive practice under existing consumer protection law.
So the message is, clean up your act or face enforcement.
Basically, yes. If your product is consistently misleading consumers about facts, intentionally or unintentionally, you are exposing your company to significant regulatory action.
The U.S. approach has also involved these voluntary measures, right?
Yeah.
Particularly concerning deepfakes and misinformation.
Yes, that's been a notable element. The White House secured voluntary commitments from several major AI companies, Google, OpenAI, Meta, others.
Commitments to do what?
Commitments to develop and implement robust, standardized watermarking and content provenance tools for AI-generated content.
Watermarking, like invisible tags.
Potentially invisible, or metadata tags, yeah. This initiative is aimed squarely at mitigating the spread of AI-generated deepfake misinformation by ensuring that synthetic media images, video, audio, maybe even text, can be reliably identified as having been created or modified by AI.
Even though these are voluntary pledges.
They set a powerful expectation. They signal what the government, and arguably the public, considers responsible development and deployable safety standards in this area. It puts pressure on the whole industry to adopt similar practices.
Okay, now let's pivot across the Atlantic to the European Union. They've taken arguably the most comprehensive legislative approach globally with the EU AI Act.
Absolutely. The EU AI Act is poised to set the global standard for AI regulation. It's expected to begin enforcement phases around 2025. And to understand its mandate for factual accuracy, you really have to look at their risk-based approach.
Risk-based? How does that work?
The Act categorizes AI systems into 4 tiers based on potential risk. There's unacceptable risk systems, which are essentially banned things social scoring by governments. Then high risk, limited risk, and minimal risk.
Where do the big generative AI models, the ones prone to hallucination like ChatGPT or Claude, fall in that categorization?
That is the critical nuance that's often missed in headlines. Generally, the base, general-purpose generative AI models themselves are initially considered limited risk.
Okay, limited risk sounds not too bad.
But here's the catch. If those same models are deployed for specific, sensitive applications, things like determining someone's credit score, or being used in medical diagnostics, or in critical infrastructure management, or even in recruitment software,
then the application becomes high risk.
Exactly.
Yeah.
The use case triggers the high-risk classification. And the AI Act mandates that providers of these high-risk AI systems must meet very stringent requirements before they can be placed on the EU market.
And those requirements relate to truthfulness.
Yes. Among other things like data governance, human oversight, and cybersecurity. They must ensure a certain level of factual accuracy, implement strict technical documentation, conduct risk assessments, specifically looking for bias and error, and implement robust risk mitigation measures. Plus, high transparency is required.
So the Act essentially requires developers to engineer hallucination mitigation directly into the high-risk systems they want to sell into Europe. You can't just release it and hope for the best.
Precisely. This is what we might call the source mandate regulating the creator of the AI system. Furthermore, the Act explicitly mandates specific transparency measures for many AI systems, including clear content labeling or watermarking for all synthetic content generated by AI unless it's obviously artistic or satirical. Providers must actively assess and mitigate systemic risks, explicitly including the dissemination of misleading content.
But the EU has another major law that interacts with this, right? The Digital Services Act, the DSA.
Yes, the DSA is essential because it complements the AI Act by targeting the distributors of information, not just the creators.
Distributors like.
It applies particularly to very large online platforms, or VLOPs, think major social media networks, large search engines. The DSA requires these platforms to assess and mitigate systemic risks present on their networks.
And those risks include AI-generated misinformation.
Absolutely. The spread of misinformation, including deepfakes and AI-generated falsehoods, is a key systemic risk under the DSA. So while the AI Act might target the company that created the hallucinating model or the high-risk system,
the DSA mandates that the platform where that content might be posted or spread also has responsibilities.
Correct. For example, the DSA requires platforms to have systems in place to label known deepfake content circulating on their networks and to enforce their own policies against malicious misinformation campaigns, regardless of whether the source was human or AI. It creates a more robust safety net, covering both the creation and the distribution channels.
What's fascinating here, and we see this often with EU tech regulation, is the potential for a massive global ripple effect.
The Brussels effect.
Exactly. The EU is effectively setting an international bar. Global companies, even those based in the US or elsewhere, will likely have to build in these transparency features, these factuality safeguards, these watermarking capabilities, just to be able to operate legally and sell their AI products within the large, lucrative European market.
It forces a global baseline, essentially. If you want access to the EU market, you need to meet their standards, which often means applying those standards globally for efficiency.
Okay, let's pivot one more time, now to China. Their regulatory approach around AI content seems perhaps the strictest, and it's heavily intertwined with state ideology and control.
That's definitely the case. China's regulations, notably the interim measures for generative AI services that came into effect in 2023, place extremely high demands on providers of generative AI.
What kind of demands?
They have these dual requirements. First, the generated content must adhere to principles of truth and accuracy, similar to elsewhere. But second, and crucially, it must also rigorously align with the country's defined core socialist values and must not undermine national security or social stability.
So the hallucination problem isn't just a technical flaw there.
It's a potential political or ideological threat. If an AI hallucinates information deemed harmful to social stability or counter to state narratives, that's a major compliance failure.
How does that translate into accountability for the tech companies operating there?
The accountability is extremely high, and enforcement can be swift. If an AI model hallucinates politically sensitive misinformation, the provider, the company that developed or deployed the model, is held strictly accountable under the law.
How do they try to prevent that?
Providers must undergo mandatory, rigorous security assessments before launching their services. They have to effectively prove to the regulators that their models are sufficiently filtered, controlled, and aligned so that they won't generate disallowed or harmful content, including factual inaccuracies that touch on sensitive topics.
And have we seen actual enforcement examples using this framework? People getting in trouble?
Yes, absolutely. Chinese authorities have arrested individuals for using AI, sometimes even accessing models like ChatGPT via VPNs, which is restricted to generate entirely fake news stories or rumors that subsequently went viral on Chinese social media platforms.
What does that show?
It demonstrates that the legal system in China isn't really making a huge distinction between human-generated fake news and AI-generated fake news in terms of liability for spreading rumors or disrupting public order. The law treats the harmful output similarly, regardless of the tool used to create it. They aren't waiting for perfect technical solutions. They are enforcing existing laws regarding content responsibility right now. So if we try to synthesize all this, connect it to the bigger picture of the global legal implications, the trend is really undeniable. The era of AI developers being able to release models that lie or fabricate with impunity and just shrug it off as a technical glitch, that era is rapidly ending.
The law is catching up.
The law globally is pushing AI development strongly in the direction of truthfulness by design. It's requiring systems to have mechanisms to verify information, to cite sources, to be transparent about their limitations and outputs, and it's demanding that the creators take palpable legal responsibility for the factual integrity and safety of their systems. The pressure is immense.
Okay, so if the technology itself is improving, and the law globally is pushing hard for truthfulness and accountability, the ultimate stake here, maybe the most important piece, is public faith, consumer trust.
Absolutely. Every single time an AI makes a prominent factual error, it chips away at that trust. And we've had some very public, very expensive chips already.
We have to recall those high-profile failures that really defined the industry's early credibility crisis, don't we? Like Google's initial demonstration of its Bard chatbot back in early 2023.
Oh, yeah, the James Webb Space Telescope error.
Right. In its own promotional material, Bard confidently delivered a completely false fact about discoveries made by the James Webb Space Telescope.
A mistake caught quickly by astronomers online.
And that single error on just one query in a demo was reportedly so impactful that it contributed to a massive drop, something like $100 billion in Alphabet's stock market value over the following days.
That is the tangible, brutal, real-world financial cost of a single public factual hallucination from your flagship AI.
It showed the market and the world that the technology, while incredibly advanced in some ways, was still fundamentally unreliable for basic factual retrieval in a way that really mattered. Its credibility took a huge hit right out of the gate.
And the reputational damage in professional spheres has been equally severe, if less headline-grabbing financially. We keep coming back to those anecdotes, which are real cases of attorneys being sanctioned by judges
For using AI-generated fictitious case citations in legal filings.
Exactly. That proved definitively, in a very high-stakes field, that these AI tools could not be relied upon blindly. They require rigorous human verification, especially when the consequences of error are significant. It eroded trust among professionals who might have otherwise been early adopters.
And it feels like general skepticism is now widespread, right? Most consumers who've used these tools are aware that they have this propensity to just make things up sometimes.
Surveys absolutely confirm this general awareness. One influential study found that around 39% of consumers reported having experienced what they perceived as low-quality AI responses, which includes irrelevant answers but also factually incorrect ones.
And the effect.
The study showed that this experience consistently undermined their overall trust in the tool and their willingness to rely on it for important tasks. So, yes, the trust deficit is real, and it significantly limits the technology's practical application, especially in areas where accuracy is paramount.
You know, trust isn't strictly binary, it's not on-off, but repeated factual errors. It's kind of like having a human assistant who's brilliant sometimes, but just constantly makes stuff up other times.
Eventually, that assistant is going to get fired.
Or at least they'll be relegated to only doing trivial tasks where mistakes don't matter much. You wouldn't trust them with anything critical.
Which is exactly why the AI developers are now hyper-focused on transparency. Transparency is being framed as the key component of rebuilding that trust. They are proactively trying to set the correct expectations for users now.
Moving away from selling the idea of perfect, infallible intelligence.
Right, more towards, this is a powerful tool, but here are its known limitations.
And this is where documentation like model cards and system cards comes into play. We're seeing more of those.
Exactly. These documents, like the detailed GPT-4 system card that OpenAI released, are becoming essential. They explicitly detail the model's capabilities, its training data scope, its performance on benchmarks, but crucially, also its known limitations and failure modes.
Including hallucinations.
Yes, including its tendency to hallucinate under certain conditions. They might even provide specific examples or quantify the hallucination rates observed during testing. This kind of upfront honesty is required because users are much less likely to overtrust the AI and then be badly disappointed or harmed if they are given clear, documented limits on its performance from the start. It manages expectations.
And alongside that documentation, we also see the simple, but now almost universally deployed, user warnings and disclaimers right in the interface.
Yeah, nearly all major generative AI services now feature those prominent disclaimers. You know, like ChatGPT's standard warning banner may occasionally generate incorrect information or may produce inaccurate information about people, places, or facts.
What purpose do those serve? Is it just legal CYA?
Well, it serves a dual purpose. Partly, yes, it's about managing legal liability by warning the user. But it also serves to constantly encourage users to adopt a basic level of vigilance. It's a persistent reminder. Don't take everything you see here as gospel. Double-check critical outputs.
Okay, perhaps the most concrete and maybe enforceable trust-building measure we're seeing emerge is this focus on source provenance and watermarking. The idea that the AI needs to show its work.
Yes, source citation is becoming fundamental, particularly in those grounded chatbots that use RAG. When the system cites its web sources or document sources for each statement it makes.
It allows for immediate user verification.
Exactly. Click the link, check the source. That directly bolsters confidence if the source checks out. But beyond just text citations, the push for broader content provenance tracking across all media types is massive right now.
Organizations like C2PA.
Right, the Coalition for Content Provenance and Authenticity, C2PA. It's a cross-industry group developing technical standards to allow for cryptographically signing digital content, text, images, video, audio at the moment of its creation or modification.
Like the Adobe Content Credentials feature, we're starting to see integrated into tools like Photoshop.
Correct. That's a real-world implementation of these C2PA standards. The goal is to create traceable AI output across the board.
How does that help with trust?
This cryptographic signing, this digital watermark or metadata, ensures that users and downstream platforms or applications can reliably know if content was AI generated and potentially which model or tool created it, and maybe even if it was edited later.
So if AI outputs become reliably traceable and labeled,
Then users can apply the appropriate level of scrutiny based on that knowledge. The industry is aiming to establish a clear chain of trust, or at least a chain of origin. If we know for sure this biography was written entirely by LLM Model Y, then the user can calibrate their trust based on what they know about Model Y's known limitations, from its model card perhaps, rather than having to guess if it was human or AI. It moves us past blind faith towards informed assessment.
so looking to the future, pulling all these threads together, the tech improvements, the legal pressure, the transparency efforts, where do you see consumer trust stabilizing? Will people ever fully trust these things for facts?
I think trust will ultimately build or rebuild when two critical factors really converge and mature. First, we need the actual measurable improvement in accuracy to continue. Hallucinations must become genuinely rare events, approaching the reliability we'd expect from a competent human expert in a given domain. The 3% rate is better than 15%, but it needs to get even lower for high-stakes use.
So performance needs to keep improving drastically. What's the second factor?
Second, we need sustained perceived honesty from the providers. This comes from that comprehensive transparency we talked about, the model cards, the clear warnings, the reliable watermarking, and source citations. Users need to feel the companies are being upfront about the risks and limitations, not trying to hide them.
So it's a combination of the AI actually getting better and the companies being more honest about its current flaws.
Exactly. The ultimate goal, I think, isn't necessarily to get users to have blind absolute trust in AI. It's probably more realistic and healthier to shift users towards a pragmatic and informed trust but verify approach.
Where the AI provides the first draft or the research assistant.
But the human user remains critical, vigilant, and uses the transparency tools like citations and watermarks to facilitate their verification process. Trust becomes conditional and context-dependent, not absolute.
Wow, what an incredible journey that was, really diving deep into this global fight for factual AI. We started by defining that profound problem underscored by that early 58% truth gap you mentioned. Just shocking.
A huge gap to overcome.
Then we explored the really ingenious technical solutions being deployed. RSAID bringing in external grounding, RLHF trying to align the model's behavior towards honesty and admitting ignorance, and clever prompting like COPE, encouraging deeper, more verifiable reasoning.
And we looked at how we measure progress, the complex metrics needed from TruthfulQA, testing resistance, to common internet myths, to fever-checking evidence use in a closed world, and FActScore meticulously measuring the precision of those tiny atomic facts within long-form generated content.
And then the legal hammer coming down. We saw how the global legal frameworks are tightening everywhere, demanding transparency and accountability. The EU's AI Act is really forcing high-risk systems towards truthfulness by design, mandating things like content labeling.
While the FTC in the U.S. is leveraging existing consumer protection law to pursue deceptive practices, and China is imposing strict ideological and factual accountability directly on the providers. There is no escaping regulatory scrutiny anymore.
If we try to connect all this to the bigger picture, it feels like the pursuit of factual, reliable AI is absolutely essential for unlocking its truly vast potential. We can't have AI transforming education or healthcare or advanced science if we can't trust what it says.
Precisely. The intense pressure from regulators, the massive financial cost of public failures like the Bard demo, and the clear market demand for reliability, all these forces are successfully pushing AI development toward this concept of truthfulness by design, where the ability to verify, to cite sources, to be transparent about limitations becomes an inherent expected part of the system architecture, not an afterthought.
Yeah. In a world already drowning in fake news and misinformation, AI absolutely must become part of the solution, not just a powerful new source of confusion.
That's the hope and the challenge.
But the progress we've seen, moving from those early models scoring maybe 58% on truthfulness benchmarks to today's improved, much more calibrated scores, even if not perfect, it is incredibly encouraging. It really suggests that tomorrow's AI has the potential to be a far more trusted and perhaps more trustworthy partner in accessing information. So the final challenge, the final thought for you, the listener, as you navigate this evolving landscape, is maybe to consider this. What specific role does something like mandated watermarking or clear source provenance play in your personal consumption of news and information online? How will you adjust your own level of trust, your own verification habits, based on knowing the provenance of a piece of content? Knowing definitively whether something was authentically human-created or synthetically generated by AI, how does that fundamentally change how you interact with information and what level of scrutiny you apply? It's something we'll all be grappling with more and more.